Yeah, greetings to everybody, and welcome to this class of learning through maths through origami. So in this class, I'm going to show you two concepts which you can actually use in home to basically teach basic concepts of mathematics through origami. So first, I'm going to start with the first demonstration, which is basically understanding the properties of diagonals of a square, right? So let me just quickly go ahead. So let's take a square which you see on screen now. So a square which is named as ABCD, and I'm going to draw a diagonal AC, right? Then there's a second diagonal called BD, and these diagonals intersect at a point called O, which is the intersection point of these two diagonals. You can see it with a red point on screen, which is marked as O. Now, what I have to prove here, or what I would like to prove here, is to prove that the length AO is equal to the length OC, right, which is marked as orange on your screen. And similarly, with what I would also like to prove is the length OD is equals to length OB. If these lengths are equal, then you can take a compass, use O as the center, and then take radius as OB, and then try to draw a circle, and what you will realize that the circle passes through all the vertices of the square. If that is true, then what we can say is the length of the vertices, or the distance of the vertices from the center O, which is marked as red point here, is equal from all the vertices, which means that all these lengths are equal. Now I'm going to go ahead and I'm going to use a paper to basically demonstrate why these lengths are equal. And let me just go to my camera here. Okay, so here we are. You can see me on camera, and here I have marked, here I have this red paper, right? And in this red paper, what I have done is I have marked these diagonals, which you can see a diagonal here and a diagonal which is here, right? And they intersect at a point called O, as I've shown you before, right? Now I have to prove that this length is equal to this length, and this length, right, is equal to this length here. Okay, I have marked them as one single cut here, like you can see a single cut here and a single cut here. So I want to prove these two lengths are equal, and I have used a double cut here to show that this length and this length are equal, right? Now just think about it for a moment, that how will you go about doing it. If you have any ideas, feel free to put your ideas in the comment section. I'll just give you 1 minute, we'll wait for it, and then I will sort of go ahead and try to tell you how this can be done by paper folding. Think, think hard. Feel free to put your comments in the comment section, your ideas. If you'll share your ideas, I think maybe other people also get some hint as to how to go about doing it. Okay, so let me just go and do it. So I'm going to take this paper and I'm going to take one of these diagonals and I'm going to fold the paper along that diagonal, right? So this is how I have folded it. So you can see this fold here. Okay, so you can see this one diagonal has now become the edge, and from the front it looks like a triangle, right? And can you see these two cuts here? So can you see this one cut here and a one cut here, right? So these are these double cuts. Okay, so these are these two lengths which I initially asked you to prove that they are equal. Okay, And the next step would be to see this line here, right? The other diagonal which you can see there. I'm going to take that as a line and I'm going to fold this paper. Okay, so now what you see that it has become a triangle. But if I show you this side, what you will see is that this and these two edges have matched. If they have matched, that means these two lengths are equal, right? So these two lengths are equal. Fair enough? Okay, so I'm going to take this and I'm going to unfold it. Yeah. So this is how I proved that this length and this length are equal. Got it? Fairly simple. I mean, this is something which you can try at home. Basically, just to teach your children how to basically understand geometry just by using these simple papers. Okay, so here is the next question to all of you. Now, I'm going to take the same paper here. Here is the same paper. And I'm going to fold it again along the diagonal. And I'm going to fold it. Okay, now I folded it here. Now what you see here is one single cut here and a one double cut here. Okay, now what I want to prove here is that this length is equals to this length. And how can I do it? So think of an imaginary line here in the center. Like I'm going to, sort of fold this paper along that line, give it another fold. And what you see is that these ends have matched here. And now what you see is these two lines, this line and this line, are now overlapping. Okay, so they now overlap, and that's how you can prove that this edge of the triangle is equal to this edge of the triangle, which is this double cut here and a single cut here, right? Which I'm going to open it up, right? So this double cut here and this single cut here, they are both same. That means this length is also equal to this length. And that is the reason why when we used the compass and we use this as a center and this as the radius and we drew a circle, it passes through all the vertices. That is what I showed you through the presentation on screen, right? So that's how you talk about the properties of the diagonals. So in summary, in a square, the two diagonals intersect at a point O, right? And they bisect each other. That means the center point O splits the diagonals into two equal halves, right? And similarly, it happens for the other diagonals as well. And this length of one diagonal is equal to this length of the other diagonal. Okay? So this is my first part of the presentation. Okay? If you have any comments, any ideas, please feel free to comment in the section. I'll wait for like about 30 seconds now, and then I will go to the next part of the presentation, which is how to find the sum of the series, a simple series, but you can actually use your papers to basically convince how this sum is found out just using paper. So feel free to put your comment in the comment section. Okay, so I'll go to the next part. Okay, so here in this part, we are going to find the sum of the series using paper folding. Okay, so before I go to the paper and I show you how to find the sum of the series, I have to tell you what the series is and what is the question which I'm trying to ask. Okay, so here is a question. So think of a series where the first term is half, followed by 1/4, followed by 1/8, followed by 1/16, followed by 1/32, and followed by 1 by 64. So you have a series here, and every subsequent term in the series is half of the previous one. Now the question is basically what is the sum of the series, right? So you have to find the sum of this series. So think about it, and then I will go to my next part through which, using paper folding, just by plain simple paper folding, I'm going to convince you how a sum of the series can be found out using paper folding. Think about it. Put your comments in the comment section. Okay. So here I have a paper, right? I have written these parts, but I'm going to tell you what these numbers on the screen are. But actually, if you go through it, you can see the same terms which are there in the series, right? You have half, you have 1 by 4 here, you have 1 by 8 here, then you have 1 by 16, 1 by 32, 1 by 64, and so on and so forth of the other terms of the series, right? Now, I will tell you how these numbers have been generated using paper folding, okay? So here is one full paper, right? So let me just move back a little bit back. So here is one full paper, and what I'm going to do is I'm going to fold this paper into half. So what you see on screen is half, which says this is half of the paper, right? Now I'm going to take this half of the paper and I'm going to give it another fold. The moment I give another fold, what you see on paper is 1 by 4th. Now this 1 by 4th says that this is 1/4 of the paper. Now I'm going to take this 1/4 of the paper and I'm going to make it half again, right? So I'm going to fold it into half, and what you see here is 1/8, right? So this is half of 1/4, which is 1/8. Fair enough? So you understand what I'm doing? Every time I'm folding the paper into half, I'm writing what that area represents in terms of the fold. Okay? Now I'm going to fold it further, so the paper is going to become half, and then what I get is 1/16. Now does it make sense? Like those numbers which I have written is basically have been generated by folding these papers subsequently. Okay? Now I'm going to unfold this paper. I'm going to unfold it again, and this is what you get. You get half of the paper, you get 1/4 of the paper, you get 1/8 of the paper, you get 1/16 of the paper. Now if you fold it further, what you're going to get is 1 by 32 of the paper, 1 by 64 of the paper, then 1 by 28 of the paper, and so on and so forth. So you keep making it half, and this area, which is this half, becomes smaller, 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 and it keeps becoming smaller. Now if you keep doing it as long as possible, right, you keep doing it, you keep doing it, you keep doing it, then this area will become smaller and smaller and smaller and smaller and smaller and smaller, right? It'll keep becoming smaller to the point that it will almost reduce to a point or even smaller than that. Okay. Now, because of the practicality of the folding, for me to fold the paper beyond 1/16 is going to be a difficult affair. Maybe I can go to 1 by 64 at max, but I think beyond that, it's very, very difficult. So that's why I didn't sort of really try doing it on the video here, but you get the idea, right? What exactly I'm trying to say here. Okay, now just take a step back and just think, if you add all these areas, which is 1/2, 1/4, 1/8, 1/16, 1 by 32, 1 by 64, if you keep adding it, what exactly are you going to get? I'm sure the answer is very obvious to you all. what exactly are you going to get if you keep adding these areas? I know you all can sort of come up with the answer. It's very obvious. Just think about it. It's just very common sense. So what exactly I'm going to get is one full paper. Does it make sense? So all the parts of the paper, if you add them together, you're going to get one complete paper, right? Now somebody can say, like, what about this small part? Like this very, very small part as you keep going ahead and keep making it half, and further half, and further half, and further half. I mean, I do understand where your doubt is coming from and where your concern is coming from, but that part you can always ignore. What you can say is, yes, the sum is very close to 1. It is so close to 1 that you can actually say it is 1, right? It is something like 0.9999999999999. You keep adding 9, you keep adding 9, you keep adding 9 as long as you want, right? So it's basically 0 followed by decimal followed by as many 9 as you want, right? That means it is so close to 1 that you can actually say this is 1. Okay, so this is fairly simple, right? So the whole idea is that you can take the same series here. Let me just go back to the same series here. Now this sum which I asked you to find out, this sum which is there in this red square bracket here, which I asked you to find out, which is 1 by half plus 1 by 4 plus 1 by 8 plus 1 by 16 plus 1 by 32 plus 1 by 64. This sum turns out to be 1. Right? Isn't this very simple? Right. So my point of this video was to basically show you how you can use a simple paper folding technique to basically teach certain concepts of mathematics in a very simple way to a child, right? Now, if you see this series, these kind of series actually appears in grade 11th and grade 12th, right? Now, a concept which comes up in grade 11th and 12th, this is actually a part of geometric progression, which is covered in grade 11th and 12th. This concept can actually be taught to someone who is from grade 6 onwards, right? Somebody who's in grade 6 can actually pick up this concept. And just by paper folding and writing these numbers on the paper, and you can ask the question to the 6th grader, and I'm sure that person most likely should be able to give you an answer of 1, which is 1 full paper. So I hope you all enjoyed the video. Feel free to share it with your friends. Try doing this activity at home. Take a square paper and try to just fold it and show the properties of diagonal, or this second part which is finding the sum of the series, and try to show this magic to your kids, right? And if you have any inputs which you want from my end, please feel free to put that your comments in the comment section, and I'm sure I should be able to address it in a follow-up post, right? So there's a lot which we can do through origami. I'll get back to you in a second video next week, and I'll try to teach few more concepts using paper folding and origami. So thank you. Have a good day. Bye-bye from Quebec.